All right, let's get this show on the road. Welcome to our webinar on the Analytics Easy button, how to deploy ClickHouse services with Terraform, Helm, or Argo CD. My name is Robert Hodges. I'm CEO of Altinity, and it is my delight to be doing this with Josh Lee. He is the Altinity developer advocate, and will be taking this show on the road. Very quickly before we dive in, I just want to bring up a couple of things that will help improve your enjoyment of this. First of all, this is being recorded. That's a common question, and we will send you a link to the recording and to the slides within 24 hours of this webinar completing. Second thing, we have plenty of time for questions. You can pop them into the chat or the Q&A box as the talk is going on. If they're relevant, we may just stop and check them out right then and there. Otherwise, we'll batch them up and answer them at the end. And Josh, I'll do one last part, which is the beginning of the intro or the introductions. So I'm Robert. I have been working on databases for over 40 years now. Been working on Kubernetes since 2018. My day job is running the ClickHouse business. And just a little bit about Altinity. We are an enterprise provider for ClickHouse, which is to say helping people build high-speed analytic systems. Our products, which are many, include things like Altinity.Cloud, which is a cloud service for ClickHouse. We'll be showing you a little bit about that as part of this. Also, Altinity Stable Builds. Some of you on this call are no doubt using them. And we're also the authors of the Altinity Kubernetes operator for ClickHouse, which is the most popular operator, perhaps really the only one that's widely used to run ClickHouse clusters in Kubernetes. Josh, I'll turn it over to you to introduce yourself and take it away.
Sure, absolutely. Thanks, Robert. So I'm Josh Lee. I've been a developer. My background is as an application developer. I've been doing it for over a decade. Most recently working in observability and hoping to bring a little bit of an application developer perspective to this platform engineering thing that we're doing. Because really, what is a platform but a SaaS for our internal customers? All right. So with that, let's take it away. So what's in a platform, right? As I just mentioned, it's kind of like a SaaS for our internal customers. I'm starting to think of a platform kind of like a neighborhood, and all of the infrastructure and utilities that come with that, and the applications, of course, are the houses in the neighborhood. And there's a little bit of a hint in the way that this diagram is drawn, that we kind of have the things above the surface and below the surface, right? And below the surface, we have platform. It's just everything under the ground. It's one big mess of things, wires, pipes, dirt, all thrown together. And above the surface, we have our nice, neat user-facing applications. But of course, in reality, it's actually a little bit more complicated than that. We see there are multiple layers beneath this nice quotidian house. And actually, if we start to divide it up a little bit, we see that we have the applications that make up our platform running underneath the applications that our end users are using. And all of that, of course, is supported by the infrastructure. And of course, we know that we have our DevOps tools for this, right? We have Argo CD for deploying the applications. We might be thinking we'll use Helm for all of our platform applications, because that's the tool that the SRE team wanted to use. And of course, Terraform, right? The hint is in the name there, Terraform. It's the base layer of our infrastructure. We're moving the dirt around, getting things ready for construction. But it's still a little bit more complicated than this. And so we're going to dive into that a little bit in our real example that's coming up. So how are we actually using these tools? We're not strictly using them along those boundaries that I just defined. Terraform is great for managing infrastructure that lives for, I say semi-permanent, that's a relative term, right? I mean longer than the life cycle of a deployment or a container, or these ephemeral things that we have that make up our services and applications, right? It's part of the infrastructure that other things are going to depend on, and it's going to be around for a while. So that's the things like VMs, clusters, your operators that run in those clusters and maybe manage your services, or the managed services that run alongside your clusters, providing databases and queues and things like that for your applications. Observability and security services would also fit into that, right? So Terraform is really great for this because of the way that it manages state, and it won't make changes without knowing how those changes are going to affect the state of the entire system, right? It kind of has these checks and controls, but it's not great because of that strict state management, right? It can actually be kind of a pain when you have multiple teams trying to use it to deploy applications. So it's not really great for that application layer where things are more ephemeral and there are more cooks in the kitchen, so to speak. Then we have Helm. So Helm, I think, is everybody's starting point when you're first working with Kubernetes and you go through your first tutorial and deploy an application. It's where we'll start. And Helm templates are awesome. I love Helm templates. They're such a great way for defining applications. Personally, I think Docker Compose files are the best way to define applications, but that's a story for another talk. Helm is great for defining applications and the various components that make them up. But the actual Helm API, as it interacts with the Kubernetes API, it's kind of redundant. It's recreating some of the controls and checks that are already built into Kubernetes. And it's also redundant with other tools that we might use, like Argo CD. So in the example that we're going to show you later on, we're using Helm heavily, but we're really only using it as a templating language. We're not using it to interact with the Kubernetes API, and we're not deploying Helm releases to Kubernetes. We're going to be using Argo and Terraform to manage all of that sort of thing. And then we get into Argo. So this is the top layer of our stack. And this is part of an API that we might say expose to our application team so that they can deploy their applications. We might also use it for deploying things in that platform applications layer, like our observability stack or our security stack. And it's great because it can inflate the Helm templates for us so that we can see all of the YAML that's going to get applied to our cluster before it actually gets applied, and we can see the complete diff before running the release. So this combination of sort of using Helm for templates and Argo for inflating and applying those templates is a really, in my opinion, just safe and efficient way to deploy applications to Kubernetes clusters. App of apps pattern is pretty familiar, so I won't go too deep into it, but for those of you who are not immediately familiar with it, essentially an Argo application is just a CRD or a CR in Kubernetes that has the type of application, and it's really just a Helm chart, right? It has template, it has this templates folder, it has a chart.yaml, it's a Helm chart, and all of the templates will get deployed as part of that application. And if each one of those templates is another Argo application, then Argo will go ahead and follow up with the instructions here to deploy that application from the source. So here we're defining these applications as a third-party Helm chart and some custom values that we've defined. We're pointing to the values on the public GitHub because what Argo is going to do is it's going to pull down this Helm chart, and then it's going to pull down these values and inflate the Helm chart with these values and then apply it to our cluster. It's pretty handy. And we can drop as many apps as we want in here. We could even drop an entire Helm chart in here if we wanted to, instead of referencing a third party one. And Argo would dutifully deploy it. And I'm going to hand things over to Robert really quickly to explain what ClickHouse is and how this would sort of fit into a platform that we might be building.
Great. Yeah. Thanks, Josh. So just a short detour here to talk about ClickHouse. ClickHouse is basically the core of any system that is processing a large amount of data and wants to do it quickly. So if you haven't heard of ClickHouse before, it's a real-time analytic database. And I like to think of it as the offspring of the marriage of a database like MySQL, which many of you on this call are familiar with, and a database like Vertica, which is one of the pioneering data warehouses. So from the MySQL side of the family, we get the fact that it understands SQL, of course. It runs practically anywhere. It's it's open source, of course. This is one of the reasons why MySQL and databases like Postgres became phenomenally popular, was because you could use them anywhere you wanted. And so that's those are sort of the the MySQL types of things. It's also, I should say that ClickHouse is also pretty friendly to use. It has a a SQL dialect, which is not standard SQL, but has some similarities to MySQL. So if you've been in that environment, you'll find it quite familiar. Uh, from the data warehouse side of the family, we get the fact that it was originally designed with what's called a shared nothing architecture, which is basically where you have a bunch of server nodes. They each have their own storage. That model is actually being slowly erased as ClickHouse evolves, but it means that you don't have to install fancy file systems or do anything complicated. You'll just bring it up and it simply works. It stores data in columns. This is the most important thing about the data organization. Um, that means that if you, for example, have a table with 100 columns in it and you run a query that only uh, references 3 of them, that's all you read. Moreover, that data, because it's in columns, can be compressed extremely well. This is one of the side effects of that type of storage. So this organization of the data makes it phenomenally good for reads. Speaking of reads, ClickHouse also is designed to apply compute very, very efficiently when scanning those columns, for example, to compute averages or histograms or other things. It can both use what's called vectorized execution, where it treats the columns as chunks of arrays. It loads them into uh, uh, basically loads them into the CPU as quickly as it can. The arrays uh, allow you to take advantages of things like single instruction multi-data, so that you get parallelization of operations. And it can also parallelize very well across nodes. So these things are all connected by a network, and you can set up ClickHouse tables so that they will spray data or spray queries across a bunch of nodes at once and give you a faster answer, scanning more data. And then speaking of scaling, it runs into the petabyte range. It's been many years since people have crossed, for example, a 10 petabyte boundary. There are some very, very large clusters out there. And so if you start with ClickHouse, and as long as you write the application well, it will basically scale up as you can add more resources and scale the system up as you get more data and more users. And as a result, it's become phenomenally popular. It's one of the most popular data warehouses on GitHub. Has 30, 40,000 stars, hundreds of people contributing to it, and it's just a great database to make the core of your system if you're doing observability, security management, network analytics. It's a great core service to have inside that stack. Back to you, Josh.
Yeah, thanks. I really just love how you can run it on anything from a Raspberry Pi to an entire cloud. So speaking of databases and being able to run them anywhere, where do they fit into our platform? And we've been thinking of a platform as being this layered thing, like an onion or a parfait. And just like a real parfait, as we start to use it, as we start to eat it, the layers are going to kind of start to mix and blend together, and things are going to get a little bit confusing. And also, like a real parfait, some of those layers might be repeated. We might see things like a ClickHouse in the top layer, the middle layer, and the bottom layer of our stack, depending on who's using it and what they're using it for. So we can kind of start to break it down into more layers than we originally had, right? So here we're starting to build everything on top of Kubernetes. We're starting to build our platform on top of the same resources that we've always had, right? Compute, storage, and networking. But Kubernetes is now kind of the operating system, the platform for our platform, if you will. On top of that, we have the services that we use to manage the platform itself. So that's things like observability and the databases and data stores for your observability data. That's things like your security stack, and it's things like your CI and CD tools. Now, these things you're going to use to manage the platform itself, but you also may be exposing them to consumers of the platform, and you also may be using them to manage those platform applications that we talked about earlier. So those would be applications that you want to run for users of your platform, so they don't have to run them inside their applications, so you don't have 17 instances of Kafka across your entire estate. And so you would have your databases, your queues, your things like ClickHouse, PostgreSQL, and Kafka, right? All of your data management. And as you get higher and higher up in this stack, we're customizing things more and more, right? Things are getting closer and closer to the actual business code that our application developers are writing. As we get lower and lower in the stack, the more things are kind of becoming standardized around Kubernetes and the tool chain around that. And with that standardization comes all of these awesome open source tools that we can use for sort of managing this bottom layer, where we don't need the custom, right? And there's also a knowledge transition here, right? Where we have the application developers kind of coming with the knowledge from their application context, and the platform operators are bringing their knowledge of Kubernetes towards the middle of this, right? So ClickHouse kind of depends a little bit on the knowledge of the application that's going to be consuming. How you deploy ClickHouse depends on how the application that consumes it will be using it, and also the infrastructure that it's going to be running on. And at a certain point, you need to bring all of that knowledge together. And we also need to bring our tools together. So we have different knowledge for different parts of the stack. We also have different tools for different parts of the stack that different people are going to use. And these tools are not exclusive, right? I already talked about how we're using Terraform with Helm, and we're using Argo with Helm, and you can kind of see that here. Ansible is just an example, right? You might be using something else for your config management, but probably you're going to have something there that you're using for the configuration management for your core infrastructure. You might be using something like op-amp if you're using OpenTelemetry collectors. You're gonna probably want something like Terraform or something that has some kind of state management for the more permanent applications that you're using to actually manage the infrastructure. So they're like infrastructure applications. And you're going to want something like Argo CD for the applications that you need to change the configuration often, or a lot of people need access to those. And again, as I mentioned, Helm is just a great templating language. So that's how I recommend using it. Right, so we have our platform team and our apps team, and I think I had my slides out of order, but we already talked about kind of how the knowledge meets in the middle to keep everybody happy. So time to get into our demo. So this is a demo. There's two parts to this. One part is production ready, and there's a QR code here and a link. This will, of course, also be available in the description for the webinar and in the follow-up email. So this is a repo that we have that's, I would say, nearly production ready. Several of us and our customers are using this and testing this out. This is a module for Terraform that leverages some of the Helm charts from Altinity, and we'll get into sort of the makeup of it in a little bit, that deploys an EKS cluster with 2 node groups, and optionally deploys a ClickHouse cluster using the ClickHouse operator and Zookeeper to one of the node groups, the other node group then being available for any applications that you would want to run alongside ClickHouse. And you can kind of see a diagram of the various AWS resources that get created by this module. And then what I've deployed on top of that is an application. So I've added, and on top of the things that we saw on the previous slide, I've added Argo CD, and I've used Argo CD to deploy just what is at this point just a toy analytics application that might be something that we can productionalize and share with you in the future. But for now, what we have is an instance of the OpenTelemetry collector, gathering a whole bunch of metrics from the Kubernetes nodes themselves, right, running as if we're trying to monitor this Kubernetes node. And then we're using the ClickHouse exporter, which is a component from the OpenTelemetry project, to export all of that data to our ClickHouse database, where we can query it using SQL, which for some people may be much more familiar than something like Prometheus. And also for things like logs and traces, it's extremely, extremely efficient, right? All of those benefits that Robert was talking about in the architecture of ClickHouse make it an excellent data store for distributed traces, which can be partitioned over time. You can benefit from that columnar data storage to get really amazing aggregates on your trace metrics. It's just perfect for that. It's also really great as a replacement for Elasticsearch for storing your logs. And you can use it for time series as well. It's really just one database for everything, which is kind of awesome, because then we can start to combine this data if we want to later on. So with that, I'm going to kind of dive into our demo. So looking at just real quick how to get here, we have the Altinity GitHub. You can see all of the projects that we maintain here. ClickHouse backup, a Grafana plugin, sync connector for Kafka, right? And one of those is this Terraform EKS module that I was just speaking about. So we can see the prerequisites, pretty straightforward. We need Terraform, we need kubectl, and we need the AWS CLI. We don't actually need kubectl configured because we're going to be creating the cluster with the run, and then it will provide us with our configuration for that. We do need our AWS credentials so that we can create all of the resources that we need and deploy the cluster. And the usage is pretty straightforward. We define a region, and we tell it that we want ClickHouse operator and we want a cluster. We can decide if we'd like to use a load balancer, or we can set this to false and set up ingress, following whatever our preference is for how we like to do ingress. And then we set up some availability zones so that we can have a highly available replicated ClickHouse cluster. We're going to set up our network masks and our node pools. M is a great shape for ClickHouse nodes. ClickHouse really loves memory, so the M shape is a great instance shape. And so we have our node pool for ClickHouse, and then we're just going to deploy for now a single T3 large, but we could deploy whatever we could really put whatever node groups we wanted here based on what our application needed, if we wanted to use this to deploy our application cluster as well. And so we deployed this, and then we also add the Argo CD definition, and we end up with Argo CD on our cluster, and we can use it to deploy applications like here where I've deployed Grafana and the OpenTelemetry collector. And we can dive into, for example, some of that that OpenTelemetry data that was being stored in ClickHouse, and now we can visualize that data in Grafana. So here we're seeing some of those node metrics that were collected. This is not very readable, but this is all of the pods and their memory usage, their RSS memory usage. We can see that there are 3 ClickHouse pods that are using a significant amount of memory relative to these other idle applications and services. And once we started adding production traffic to a cluster like this, we would expect to see those other services ramp up as well. We've got some OpenTelemetry collectors using a little bit of memory. We can also see things like CPU usage. And because this is OpenTelemetry data, it has these resource attributes. And so this is where the power of SQL really comes in handy, because these resource attributes get stored in the ClickHouse schema in a map. And so if we open up this query, we can actually see we're pulling out things like deployment names and daemon set names out of this map and using them to create lists of what we see in our cluster, right? We're almost creating service discovery just by examining these fields in the data. And so we can kind of look at what that actually looks like. So here's an example of one of the tables that's created by that OpenTelemetry exporter. We have a different table for each type of metrics just because the values are stored in different ways. But these resource attributes are the same across all of them. So we can see kind of an example of what I was looking at when I was creating that query. We have this column metric name that includes the name of the metric being reported, right? And then of course we have unit value, all of the things that we would expect for a metric. And sometimes we don't actually know what we got. So we can do something like this. Write real quick, easy SQL query for anyone who's written SQL queries before. And we can see all of the different metric names that we have available in this table. Or we could, for example, I can't see things because of this little, let's get that out of the way. Okay.
Hey, Josh, is it possible to
yeah.
make that just a hair larger?
Oh yeah, absolutely. Well, I guess just that window. Well, you can see
Yeah.
my query real nice now.
Excellent.
And let's see if we can zoom in on this too. Nope, I can't. But yeah, so unfortunately I can't zoom in on the data. But you can see then we get a list of all of the resource attributes, right? And then we can start to use this to pick apart how we wanted to write our queries in Grafana. And just a real quick view at how we've kind of set this up. So we've got our main.terraform file. This should look familiar. It's pretty much the same as the one from the example. We can see down here at the bottom, right, we've configured these outputs. This is where I said it's going to configure kubectl for you. It's also going to output the cluster URL if you enabled that load balancer. And you can ask for the password if you'd like to, and then you can use that to go ahead and create other ClickHouse users, for example, a read-only user for Grafana. Then we've got our Argo CD, right? We're deploying this using the Terraform Helm provider, and it's a pretty straightforward deployment using a load balancer service type. We are copying the credentials that were created from the EKS ClickHouse module so that we don't need to provide our Kubernetes credentials again. And then you can see this folder in the example is the Argo apps folder. So we already kind of looked at this in the slides, but just to see it again, right, here's one of our example Argo apps. Here's what it's really just a simple Helm chart that provides the templates directory. And then we can kind of see what we've all got on our cluster. This is K9s for those who are not familiar. I can definitely zoom in on this. And so we can see we've got all this stuff running, right? We've got our Argo CD, we've got our ClickHouse, we've got Keeper making our ClickHouse cluster happy, we've got Grafana, we've got an instance of the OpenTelemetry collector on every single node, we've got our ClickHouse operator, right? We've got our AWS agents and our autoscalers and all of the standard Kubernetes stuff. So that's the demo, and that's how you can deploy your own ClickHouse application using Argo CD at Terraform and Helm. And as you can see, my Keeper just restarted. So while this was pretty easy, it's not perfect, and sometimes I need a little bit of help. And so I think that's a perfect time for me to hand things over to Robert.
Great, thanks, Josh. Let's go ahead and switch the share. Just a second. Let me grab the head and bring things up into the right location and share the screen. Can you let me know when you can see the screen?
Yeah, we see it.
All right, excellent. Let's go ahead and start talking about managed services. So we'll make this a slideshow. And I'll talk a little bit about what it means to have managed services and how we can insert them into this kind of platform. And then I'll show you a demo where we actually do that. So yeah, managed services. Well, first of all, why wouldn't you just run it all yourself? And the answer for many people is, oh, by the way, Josh, there's a question here.
Yeah.
So, and I think this is really relevant. Might as well take it from Rodrigo. Do you see that one in the Q&A box? If you want to just answer that right away.
Sure. Yeah, I'll take care of that.
Okay, great.
So
Yeah.
I'll answer it live. Yeah, in the demo, using Argo to deploy analytic collector and Terraform to deploy EKS and the ClickHouse operator installation, or managing the ClickHouse installation. So yeah, that's kind of what I was alluding. So the question is, why are we using Terraform to deploy ClickHouse and not Argo CD to deploy ClickHouse? You really could do it either way, and it depends, like I said, how you're using ClickHouse. So in this case, I'm actually relying on ClickHouse as part of the core infrastructure for how I'm monitoring the cluster itself. And it's also kind of tightly coupled to the shape of the cluster, right? We have these availability zones and these nodes that I really explicitly want the ClickHouse cluster running on. So just working within Terraform, it was easier to have that interplay between AWS and the ClickHouse configuration. But it's also totally reasonable that I might be using ClickHouse as part of my application stack. Right? If I'm an observability vendor and I'm selling an observability solution to other people, and ClickHouse is part of that multi-tenant observability solution, it would absolutely make sense to have it be part of that third layer deployed with Argo, maybe in multiple instances, as part of the application layer.
Great. Yeah, and I think just to echo what Josh says, we see people mix and match this stuff all the time. And it really, for Terraform is great. The lower down the stack you are, the better Terraform is. The higher up the stack you are, the better things like Helm and Argo are. So getting back to managed services, there are substantial reasons why you wouldn't want to go it alone. I want to just say, many people just take uh, all the open source components, use the tools that Josh was talking about, put it together, manage the entire thing. They write an occasional blog article about how great it works. But for other people, there are substantial reasons why you might want to have parts of this stack managed for you. Just things like learning curves, or the fact that you spend time developing infrastructure to manage databases, and the fact that you need somebody. There's very specialized knowledge required to recover from ClickHouse failures. For those of you who use ClickHouse, detached parts is just one, or read-only replicas. These are a couple examples of things that, when they happen, you want them fixed. You want them fixed fast and safely. Managed services can, if they're well run, can help you with all of those issues. So, for example, by having somebody that's there who's an expert, you can spend less time focused on the details of the tech. Uh, by having the automation already built in, you can spend more time on your application. That's the thing that typically is going to make your business and your organization successful. And then the final thing is, when you have big failures, it's kind of nice if you can make it somebody else's problem to figure out, either to fix it automatically for you, or to back you up when you actually do have a problem, so that you're getting back up and running as quickly as possible without doing any further damage. So these are good reasons to have a managed service. But in this new world where people are you know, building things, we have this challenge to to insert management into the stacks that Josh has just shown you. So let me introduce Altinity.Cloud, and this is our cloud for ClickHouse. We opened it up in 2020, so it runs on Amazon, on GCP, on uh, uh, and Azure. Um, it is designed for real-time applications that we spent a lot of time performance optimizing it. We have baked-in DBA support, so that when you get when you have an account and when you have clusters running, the enterprise support is just built in automatically. We have very tight SLAs, and the people that you're talking to are people who have run clusters and supported clusters for many years, and know all the ins and outs of managing ClickHouse. And finally, the cloud runs on Kubernetes, and using the open source Altinity operator for ClickHouse. And we support virtually all versions and features of ClickHouse. There's a few things that we don't that you have to talk to us, but you can run the ClickHouse official builds. You can run our stable builds. Whatever is right for your business, you have full control over it. So how do we get that cloud to be added into your stack? Because what you have right here, as Josh was showing you, is a stack you've built in your own environment. And what we're going to need to do is figure out a way to make a connection to this, so our cloud, or our cloud management plane, can actually manage it for you. So there are a couple different models for how this could work, just in general. And we see both of them we support both of them. I think if you look at other products, you will see how people have taken this approach as well. So one is what we call bring your own cloud. Since the environments that we run on, as we call them, are just Kubernetes cluster, in the bring your own cloud model, you will grant us minimum privileges that allow us to come in and set up a managed uh, Kubernetes cluster in your cloud account. So for example, if you're running in Amazon, that cluster would come up in EKS. If you're running in Google, it would come up in GKE. We then put all the software necessary to manage ClickHouse, and actually run the ClickHouse clusters themselves there as well. So in that case, you really don't have to be a deep expert on Kubernetes. We will take care of that part of it for you. In other case, and for people who just want to get started, that's a great approach. Now, there are a lot of people who actually already have chosen a Kubernetes. This is very common in large organizations. They often have a customized Kubernetes version that you'll have a platform team that will give that to you. And in that case, we can't set up Kubernetes because it's already there. Instead, what we do is have a BYOK, or bring your own Kubernetes model, where we will just install software directly into the Kubernetes cluster and basically manage that. If BYOC, here's a great question. If it's BYOC, who has the responsibility to monitor the cluster? It is shared. But the our monitoring is built in, so we will not only monitor the ClickHouse clusters, but we will also monitor the state of Kubernetes underneath. So the idea here is we're keeping an eye on Kubernetes for you, and you don't have to, for example, become experts on taints or node selectors or things like that. We can also help you with, we also take care of using particular node types, so on and so forth. So I hope that answers that question. Okay, so we have these two models, and here's how Altinity handles it. So normally, and in fact, when we originally developed this, every time a tenant would sign up for us, we would create one or more environments for them. In each case, that was just a Kubernetes cluster, and they could pick in fact, you can do it right now. You can just pick the region that you want to run in the cloud. We set it up for you, and off you go. You just get an endpoint. What we do with what we call the anywhere model is it's the same basic management, but what we're going to do is install something called the Altinity.Cloud connector, and that's going to be installed inside the Kubernetes running in your account, and it's going to establish it uses Quick to connect back to our Altinity.Cloud Manager, and establishes a secure connection that can be used for management and monitoring of the stuff going on inside that Kubernetes cluster. So in this case, it's running inside your VPC. It will actually work. It doesn't depend on being in the cloud. It can actually work even in on-prem Kubernetes, but we most commonly run it in clouds because that's where most processing is these days. So that's the model. And what's going on inside? This picture is a little complicated, but if you're curious, I just wanted to show you all the parts. Within the Kubernetes cluster, we're going to create two namespaces, and we basically assign ourselves privileges so we can do everything within those namespaces. We don't need access to any other namespaces inside Kubernetes. And what we'll do is the Altinity.Cloud system namespace is where we keep our system services, like the things that observability, for example, storing data in Prometheus, the Altinity connector, Grafana to look at it. And then we have another namespace for managed ClickHouse, and that's where all your clusters live. So again, that's all inside your your VPC. One other thing is that if you want it, we will enable access through Amazon network load balancer that feeds to something that we call the edge proxy. So from this NLB, or whatever the equivalent is in the cloud you're running, it feeds to the edge proxy, which basically proxies requests into particular clusters or ClickHouse servers. So that's the innards. It looks complicated. So coming back to the question about how do we get it into the data platform, here's what it looks like. So basically, you can have everything else you want in that Kubernetes instance. The ClickHouse clusters and the Altinity services necessary to manage them fit into two namespaces. That is the part that we manage for you, and that you don't mess with. Everything else is yours to do with as you like. So that's basically how it works. Let me go ahead and show an actual demo. So let's go, first of all, let's go to Altinity.Cloud or Altinity.Cloud. Oops, I'm logged out here. Let's get back in here. All right. So here we are, and we are actually looking at what's called an environment. Let me go here and refresh this. Yeah, so here's the Kubernetes cluster. So this is the management view. This is running up in our management plane. And what it's doing is it's seeing into a Kubernetes cluster that I created in US West 2 using that nice Terraform uh, 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 script that or Terraform module that Josh showed you just a few minutes ago. So here it is. You can see all the stuff that's running in it. Um, so that one's actually fully connected. And one thing that's kind of cool is you can see the nodes. So let's go ahead and through the wonder of, here's the right one. Let's just prove that. So there we are. We see node 10.152. If we go back and look at the picture, we should be able to scroll down here, and there it is, 10.152. So I'm using K9s to look at the cluster, which I control and set up myself, and it's seeing exactly the same thing as Altinity.Cloud does. So we can also go ahead and work on clusters, and we'll come back to this in a second, but this is a picture of a cluster, and we can go in, and this is showing that we have 2 nodes. There's a bunch of information about it, and we'll look at that in just a minute. What I'd like to do first, though, is I want to come in and actually connect up a new environment. So I'm going to kick that process off. Let's go ahead and show the new environment. Oops, get to the right K9s environment. So this is cluster 20, and you can see that it has just a few namespaces. This is just the default cluster or default Kubernetes cluster in its native state. Nothing has been installed on it. Let's change that. So what we're going to do is we're going to go to environments, and I'm actually going to go in and create a new environment. And it's going to be called Bring Your Own Kubernetes. There we go. And we're going to call it Altinity, R Hodges cluster. We'll call it C20 BYOK so I can remember what I've done there. So there it is. And I'm just going to press OK. And boom, Altinity.Cloud is now ready to get a connection from this new environment. So the Cloud, the Cloud Connect or Altinity.Cloud dash Connect is a utility that you download. I've already taken the trouble of doing that. I now have to run that utility and actually connect from within my account. So I'm going to go ahead and copy this command, which is kind of long. And let's go ahead and run that. Let's confirm that we are, so kubectl get ns. Let's confirm that we're connected. There it is. And what I'm now going to do is run this nice long command, which connects me to Altinity.Cloud. So at this point, I am ready to, we're connected, and I should now be able to run a second command, which is actually going to install all the software and basically allow us to kick off the connection. So let's go into Altinity.Cloud. Here's where we're going to go ahead and deploy. There we go. If you're curious what this is, not doing anything mysterious. I'm just piping the output from this command. It generates a script that is going to create all the services that are necessary, like create my namespaces, things like that. And then it's just going to pipe it through kubectl. So I'm going to run that, and you'll see that it goes ahead and creates a couple namespaces, so on and so forth. Now, at this point, I can go back in. Let's make sure it's cluster 20. And you can in fact see I've got 2 namespaces. I'm still not fully connected up to Altinity.Cloud because all I've got is the connector here. And in order for this to run, we actually need the rest of the services to do things like observability. We need the ClickHouse operator installed, so on and so forth. Let's do that now. So I can now proceed to the next step. And here I can go ahead and begin the setup. And so I have a little bit of configuration. I see there's GP2 storage here. I don't like that. I'm going to make it go away. So we won't use that storage class. I need to make some choices about instances. So let's go ahead and we'll say that T3 larges, which are kind of cheap, are going to be used for Zookeeper and system services. We're going to use, let's see if I can go find it, M6i. It's kind of a long list here. You can see all the available. Yeah, here we got M6i. Here we go. M6i large, and we'll use that for ClickHouse. At this point, I now can kick off proceed. And what's happening right now is we'll see shortly it will begin to push uh, to push services down and install services inside my environment that I'm going to be managing. And what you can see right now is pods are coming up in the Altinity.Cloud system namespace. And this is kind of like watching grass grow. It will take a few minutes for this to come up. You see these pod crash loop or these crash loop backoffs. That's the edge proxy, which is the thing that does routing. It's waiting for a certificate to be installed so that it can correctly route traffic. Once that happens, the cluster is basically available for use. So we're going to let this stew for a while. It'll take about 15 minutes, so we won't see it by the end of this um, talk. But what we can do is now go back and visit our other environment, and we can actually show you some of the things that we can do when the thing is fully connected up. So here's our connected environment. I'm in there. Let's go to my clusters. So I've got one running there. What I'm going to do is actually start a new cluster. And let's go and let's go and change this to look at pods, actually namespaces. Oops, darn it. It should be namespaces. Ah, there we go. All right, let's go to manage ClickHouse. So we've already got something running there. Let's make another one. So I do this from Altinity.Cloud. So let's go ahead and launch a cluster. And we're going to call this demo 55. And we're going to give it a password. Oops, got to type right. All right, so got a password for the admin account. Node type, we basically only have M6i. That's the only one I'm allowing. We're going to use most of these things default. Interesting things here, I can set we know a lot about storage. So for example, we can set the throughput for volume. We'll go to the next panel. This is just a simple demo. We're just going to make one of them. So only one replica. It's going to get backed up regularly. You can see a schedule of 5 a.m. every day. Keep 7 backups. Let's do one more fun thing, which is, okay, we can leave all of this. We have IP whitelisting, all the features you'd expect in a service. Let's do a fun feature here, which I like a lot. I'm going to turn this off if it's been inactive for 2 hours. That means any VMs I have running in my cluster are just going to stop. And that means that I no longer spend money on them, which is good. And I'll go ahead and review and launch, and it gives me an estimated cluster cost. What's this going to cost? What is this going to cost to manage? And then I'm going to launch it. So off it goes. And what we'll see now is that we have this demo 55 coming up. And actually, if we come over here, it's already started to open up the zookeepers, and it's adding zookeepers. And we also see this demo 55 pod come up. So that again is something that's going to take a little while to complete. So let me go in and let's go to our good cluster. And I'll just show you, there's all kinds of things that you can do. So for example, we can rescale. This is a really great feature. We can change node types. We can change the number of shards, increase the amount of storage, so on and so forth. These are key things that we can do. You fill in what you want to have happen. Like if I want to add more shards, I would just change this number to 2 and press OK, and they would come up. Other things I can do, I can actually upgrade right here. So I can choose different builds. I can switch, for example, to upstream builds because maybe I want to go to the latest and greatest. So I can, pick different versions. And another important thing is I have monitoring, and this is something that you don't want to underestimate. Within these, when you install these in in Altinity.Cloud, you get these great Grafana dashboards which allow you to see exactly what's going on inside your cluster. So, for example, select queries, read bytes, place where all kinds of these are basic stats. We have other more detailed uh, dashboards that we use when we're trying to solve problems. One of the ones that I come to constantly is load average. It's pretty common uh, to go crazy and put too much load on ClickHouse. So you can come down here and understand, hey, am I using a lot of CPU time? Am I using a lot of uh, IO weight, load average? Am I just overloading this? When is it happening? And then you can trace back and solve the problem. That's a one of the first places I look when somebody says, hey, my server's getting unresponsive. Come down here and see what's going on. So that's the demo. We basically have, looks like oh, here we go. This guy will come up slowly once he finds the zookeeper, and we'll have another cluster. So it'll be ready in about 3 minutes or something like that. What I'm going to do now, though, is that's the demo. So I'm going to come back and go ahead and put this into slideshow mode and wrap up. So what we've seen is that you can build a Kubernetes platform for data using ClickHouse using these tools that Josh introduced. Terraform is great for cloud infrastructure and Kubernetes. Helm or Argo CD is great for deploying the platform applications, so the things that make the platform itself run, and then the user applications on top of them that run your business. The great thing is you can take your pick. It's whatever you're comfortable with, and we kind of assume that different teams will make different choices based on what they like to do and also the things they feel more comfortable with. And then if you do decide that you want to manage this, it's pretty easy to take one of these Kubernetes clusters and connect it up to Altinity.Cloud, and in that case, Altinity.Cloud uh, uh, will manage it for you. Here's some more information. Which are links, just sort of various docs, our GitHub for code. Josh already gave you the link earlier for the EKS module, which we invite you to try out, and our YouTube channel, which is where this talk will live as soon as we're done. So with that, we're done. And Josh, I think we can answer a few questions here. There's one here. Let's see. So if you change the number of shards, you still do not get automatically rebalancing of data, do you? That is correct. Yes. For now, at least, ClickHouse does not automatically rebalance data across shards. So this is a typical. This is something that's left as an exercise for the reader. Um, uh, with time series databases, what you typically do where you're reading, say, let's say you're keeping 7 days of observability data, what you actually do is you'll design things and so that once the shard is active, you'll start inserting data on it. You just wait for 7 days and it's balanced. So that's for particularly for time series data, it kind of takes care of itself. If not, you can actually you can go ahead and move things between shards. This is a known issue with ClickHouse, which is or sort of feature requests, I should say, which is being addressed, but it doesn't work right now. I see one other. What is the memory implications for continuous deployment? Please do a highlight on memory cost effectiveness by going Altinity production. Okay, so I'm going to have to guess what this is. Um, Joseph, if you want to qualify this, but the way that ClickHouse, the way that Altinity.Cloud works is it is designed for applications that need real-time response. So you have VMs, which have a certain amount of RAM allocated to them. Um, the and And then if you don't like that, or it's insufficient, or it's too much, you can scale it up or down. So I hope that's what you were aimed at. Many of the systems that we manage process extremely high levels of transactions, both millions of rows inserted per second, and then constant query on them. And so basically having these VMs with fixed amounts of memory that's always available works very, very well in those types of use cases. And if you find that it needs adjustment, it's pretty easy to see, for example, from the graphics that I showed you to be able to highlight whether you're under provisioned or over provisioned for memory, and then you can just rescale the system, and Altinity.Cloud will scale it for you. I hope that answered that question. Let's see. So I think let's look at the chat. Do we have other? We've got some chat things right here. Josh, let's see.
There was a question about GPU. Is GPU compute on the roadmap for ClickHouse?
That's a great question. There has been there have been requests for that, and actually there was work done actually as a prototype at NVIDIA a few years ago. It wasn't integrated with ClickHouse. And to be honest, the GPU request comes and goes, but it's actually not a super high priority. Um, in the ClickHouse roadmap, for example, you can go read the public roadmaps, and the last I looked, GPUs were not in there. The reason for this is that uh, it's true that some things that ClickHouse does are performance intensive, but actually with ClickHouse, it's a lot more IO intensive typically, IO and memory. So for example, if you're doing joins or you're doing aggregates, so GPUs will allow you to process things very, very quickly. But in fact, many of the queries that the ClickHouse or the problems that ClickHouse is trying to solve are not as well addressed by CPUs, because you basically have to load the data in, get it back out, so on and so forth. So right now, I don't know of work to incorporate GPUs right now. That may be happening. It would be super interesting if it did. Okay, so here's a one from Chuck. With regard to security, does Altinity.Cloud have access to data stored in the cluster? Oh, that's such a wonderful question. Thank you so much. Uh, yeah, so I hope you can see this little thing right here, Altinity Access. What I can do is we build a gate in, which basically allows you to control how much access we have as we peek uh, into your clusters. So at one level, yes, Altinity, we can see into Kubernetes. So in theory, we can get to your data, but anybody who's working on support, for example, cannot get through this gate. And basically what you do is define the data access level. So full access would say, hey, I can get in and I can not only read data in every database, but I can also change them. And so that's really high level of confidence. You want us to come in and do stuff for you. Um, Here we can set it to read only, so that we have read only. We can set it to read only access, but only for system databases, and we can chop off access completely. We can also chop off the ability for us to make configuration changes, so on and so forth. So basically, you put this gate up and you protect your data. For certain support cases, we may have to ask you, hey, can you let us in so that we can help you with this? Or you can just keep it shut off. So I hope that answers that question. Let's see. So other chat questions. Let's see. Okay, Eugene, thank you helping us answer questions. Just Josh, do you see any other questions that are remaining here?
I think we got all of them.
Yeah. Well, in that case, thank you very much, everybody. We hope this has been useful. Please do come and visit us if you'd like to learn more. So you can come to our website, join the Altinity Slack. We're really friendly. We like talking about this stuff. you can just come and ask us questions about this. As I mentioned at the beginning, we will be sending this webinar, the recording and the slide links out. You should see them in your email within the next few hours. And with that, I'd like to, Josh, thank you so much for this presentation. And yes, and for those of you who are listening, thank you for attending. You're so welcome. We really hope it helps. And come talk to us. We love ClickHouse, and we really like this sort of building apps on ClickHouse. So come talk to us, and we will gladly help you.
Yes, thanks. Thanks for.
All right. With that, we'll call it a day. Thanks, everybody. See you soon.